Let's do a review of our factors of production or resources. So land, labor, physical capital, and ideas, technology slash entrepreneurship are things that we brought up in chapter number 2, and these are going to be our main drivers of economic growth. But some are going to be a little bit more important than others. And in this particular chapter, we want to go ahead and assign each one of these factors of production, break them up just a little bit, and assign each of them a particular letter because it's going to be very important as we build up our production function. So here, land and natural resources is going to be denoted with an N. They include land and raw resources from the land, so physical land in the usual sense. Also, raw resources, natural resources, so land, rivers, oil, that type of thing. Labor is going to be denoted with L, is the mental and physical talents. So what do you know exactly how to do, and can you move this box from point A to point B? However, under labor is going to be something known as human capital as well, denoted with an H. This includes improvements to labor from training and education. So here, we're going to divide it into two different parts, labor and human capital. Essentially, the more human capital that you have, the more productive your labor is going to be. In order to improve your human capital, you should be getting some type of education, getting some type of experience, getting some type of internship, just anything that gives you a little bit more knowledge and that will make you more productive. Physical capital, denoted with a K, are manufactured items used to produce goods and services. So if we need an item in order to produce our final good or service, we say that is a piece of physical capital. And then finally here, entrepreneurship, denoted with an A, is the ability to use resources to produce goods and services. So technology, also entrepreneurship, and ideas all fall under the idea of A. So our job is to go ahead and take each one of these factors of production and see exactly how much output or how many goods and services an economy can actually produce, and also which one of these is the most important for us in terms of inducing economic growth. And I think you guys already know which one is going to be the most important just by taking a look at a base definition for all of these. So in order to see how we take all of these inputs right here, all of our resources, and to see exactly how many goods and services we can produce, we make the usage of something known as a production function. So it measures how an economy turns inputs into outputs using existing technology. So essentially, a production function is a mathematical way for us to show how all of our resources, land, labor, human capital, physical capital, and technology all combine with one another in order to turn it into a specific amount of output of our goods and services. So essentially, all we need to do is have a mathematical equation for us to build up this production function. So a function is just like that, what you see in algebra or in any one of your mathematical courses. It just relates an x to a y. It takes inputs and makes them into outputs. So the easiest way to build up this production function is just to go ahead and take a look at two particular variables first. So here, the classical form of the production function is going to just deal with two variables, labor and capital. So output is a function of labor and capital. So let's go ahead and use this production function and give you a specific form so you guys get a little bit of a clearer idea of what's happening. So here, let's take a look at the classical form of this production function. Production function. And here we have output equals a function of labor and capital. So here, the small f just tells us it's a function, it's an equation, and we only have two variables inside of it, labor and capital. And I can give you your initial amounts of labor and capital. Suppose that I tell you that labor is equal to 50, so we have 50 people, and capital is also equal to 50 as well. And the thing about this is you don't have to worry about what specific form the production function is going to take place or it's going to be. I have to provide that to you. There's a lot of research. It can be a very simple equation. It can be a very complex equation, but you don't have to worry about the equation itself because I have to provide you with that information. So an production function can be something as simple as this. Output equals labor times capital. And that's exactly a production function. It includes both labor and capital, and it tells you exactly what you need to do in order to find out output. So all you really need to do is take the initial allotments of labor and capital and then insert them into your equation. So labor is 50, capital is 50. So when we include labor and capital in this particular production function, we get 2,500 500 units worth of whatever good or service we're taking a look at. It's as simple as that. But we can make these equations a little bit more complex. We can say, hey, what happens if output is equal labor to the 1/2 times capital to the 1/2? This is something known as a Cobb-Douglas production function. It's very, very typical in economics and mathematics. But the methodology is still the same. You insert labor, you insert capital into the equation. So 50 raised to the 1/2 times 50 raised to the 1/2 times 50 raised to the 1/2. And when you put this into your calculator, it's basically going to be the same exact value, 50 here. So 50 units of output based on this production function. And once again, we can do something ridiculously simple, such as labor plus capital. We just be 50 plus 50, so 100 units. So once again, in terms of the production function, it's just relating your inputs, which are your factors of production, into a specific equation or a specific form, which I have to provide to you. All you're doing is just substituting these numbers in. So knowing this, we can go ahead and make a little bit more of a general production function, which includes all of our factors of production. So incorporating all of our resources into the production function, we have output equals A times a function of labor, physical capital, human capital, and land. According to this function, technology is going to enhance the productivity of all physical resources, so it sort of lends to its importance in this particular case. So here, technology is probably the most important factor of production just by taking a look at this equation right here. But the same methodology and the same intuition is going to hold true with this general form of the production function. So here, suppose we have output equals A times a function of labor, physical capital, land, and human capital. And once again, I have to give you a specific form. I can say maybe output is equal the product of all of these variables right here. So A times labor times capital times land times human capital. And then if I give you numbers for all of these variables, all you have to simply do is insert it into this equation. We can change some of these to plus signs, we can change some to minus signs, maybe division signs as well. But the idea still holds true. All you're just doing is taking these inputs and then seeing exactly how much output can result based on a specific form of the production function. One thing that we want to go ahead and take a look at as well is sometimes we are not interested in just output, which is the total amount of goods and services, but sometimes we're interested in output per worker. So output per worker. So here, output per worker just tells us on average how much each worker can actually produce. It's very, very similar to GDP per capita. So in order for us to get output per worker, what do we have to do with this general form of the production function? So to transform output to output per worker, we just need to divide this equation by the population. Divide equation by population. By population. In this case, population is our labor. And once we do so, we have output per worker, which equals to technology times a function of L over L, K over L, N over L, and then finally H over L. So output per worker is equal to this particular function, this production function now. And what is the final step that we can do? What's the one term that we can simplify from this? We can simplify this L over L, which equals to 1. So this basically just tells us how important each one of these factors of production or resources are going to be for us. If we increase the amount of labor, it's not going to have a huge impact on output per worker because number one, we see that labor just sort of drops out right here. It's a constant 1 in this instance. And if we increase L, all the denominators are getting bigger, which is going to make these fractions smaller. So here, we're not going to be seeing an increase in output per worker. This just tells us that our main drivers of economic growth are going to be physical capital, land, human capital, and of course, technology. So the final conclusion that we want to bring about from transforming this output production function into an output per worker production function is that having more labor or just population, L in this case, will not lead to a better standard of living. Will not lead to a better standard of living. A better standard of living. So here, labor is probably the least important factor of production. Here, we should be focusing in on technology, physical capital, land, and human capital if we want to increase the standard of living for citizens living within a country. So here we talked about the production function and exactly how we relate our resources into some type of output. And in the next section, we'll go ahead and take a look at how efficient these production processes or production functions may be.